Values today. So graphing absolute values. Your second day of it. The two different things I want you to put into your graphing calculator today. If you're in your y equals menu, I want you to go y. In y sub 1, I want you to put y equals absolute value of x. And in y sub 2, I want you to put y equals the absolute value of negative, or the negative absolute value of x. Okay? Go ahead and put those in. Graph them. Talk to your neighbor about what happens and why you think that happens. As a concern here, make sure that you're using the negative symbol, not the minus symbol for that. Otherwise, you're going to get a syntax error. You've got to use that button at the very bottom of the calculator, this one right here, that says negative. All right? Yep?
Okay, so doesn't the absolute value just take, well, I know it's like the how many slices from 0, but then wouldn't it be negative? Then putting negative, wouldn't it just be the same?
Well, when you're dealing with, well, first, did everyone get the x?
Yeah.
Okay, now if I graph those one at a time, so if I turn off my second one by unhighlighting that equal sign and just graph the first one, it shows that it's the V shape going upward, versus the second one where I graph it shows that V shape going downwards, right? Okay, so as Abby pointed out, she's saying, well, when you find it, since absolute value, it's the distance from 0. That's what you're dealing with, and distance is always positive. That's true. If I were to put 1 in here, the distance from 0 of 1 is 1. So like if I were to substitute in here 1 for x, that's still 1. So this part right here gives me 1, but now I have negative 1, right? Because that negative sign out there. So whatever this was becomes negative. That's how it's flipping it upside down.
So then if it's negative 1, it would still be negative 1.
If I put negative 1 in here?
Yeah.
Yep, if I put negative 1 in here, it's still negative 1. Yeah. Okay? Because the absolute value, the distance negative 1 is from 0 is 1. And then you have that negative outside that just drops down. Okay? So it gives you an x. So what's causing that x? What's causing that to open downward? Well, that negative sign outside. So when a is negative, our graph opens downward. So yesterday, you recall, we talked about this formula right here. Y equals a times the absolute value of x minus h plus k. Remind your neighbor what k does and what h does. Okay? K. What does k do? Yep, Declan. Good, moves the graph up and down. So if it's a positive k, it moves it up. If it's a negative k, it moves it down. Okay? So k moves the graph up or it moves it down, depending on whether it's positive or negative. That's a little small there. Let's zoom in. What does h do? Danny?
It moves it side.
Moves it side to side. So h moves it to the left, or excuse me, to the right when it's negative. Okay, it moves it to the left when it's positive, which seems backwards, right? Okay. Now, a, we've just learned that a can do one thing. What did a do just a minute ago? Yeah.
It could flip it.
It could flip it.
If it's negative.
Good. If a is negative, it flips your graph upside down. It opens downward. Okay? And maybe even that's a better way of saying it. Opens down. Okay, it flips it upside down. It also controls the slope. Okay, or how wide or how narrow that graph is. Okay? We talked a bit about that yesterday. We're going to explore that a little more today. All right. So, what I want you to do first, just a quick review. I want you to go back to this page, which you got yesterday. There are 6 problems on the back. I want you to go through those 6 problems, find the vertex, graph it, and make sure you have accurate points for all parts of the graph on this one today. Okay? I'm going to call a few of you up to come up here and put them up here in a few minutes. We'll go random numbers there. All right? There you go. Work together with a partner. Hey, just a quick review. Let's do this first one together. Make sure we're all on the same page. You remember, this is your h term. So if you think back to yesterday, we have y equals a times x minus h plus k. Okay, x minus h is inside our absolute values. This h term right here, let me get rid of this stuff so it's not distracting us here. Okay, this h term, that's when we're dealing with our vertex, that's the x value of our vertex. So whatever we have here, so in this case we have that -2. Well, remember, it's the opposite of that, or if it's whatever makes that 0. So if that's -2, we'd actually see +2 right there. That's our h value. Our k value is what's back here. That's where k is. So in this case, k is -2. So our vertex would be 2, -2. So we find that, and we graph it. Now the number out in front of the absolute value symbols, there's a negative sign. So that negative sign means we actually have a -1. The negative tells us this graph does what? It goes down. And it goes down by a slope of 1. Okay, so 1 over 1. Rise 1, run 1. Or, I guess, fall 1, run 1. So go over 1, down 1. Okay, we then have our graph there, our cool little arrows, and we're good to go. Okay, questions on that? Okay, guys, your domain stands for x, right? So my domain, this graph on the x-axis exists forever. Since it keeps going on, it would keep extending downward. It goes on forever. So if I don't want you to have to go through domain and range on this page, but if we were, our domain would be?
All real numbers.
Yeah, all real numbers. Because it exists for everything. It's expanding outward in the horizontal direction. Okay? The range, which is your y, your range starts where? On the y-axis. Starts at -2. You look at your vertex, really. You just look at that number right there. Your range is at -2 on the y-axis. Now, from -2, is it going up or down?
Down.
It's going down. So it would be less than or equal to. Could be -2. It starts here and goes downward. Cool? Whereas your domain, it's good for every x value. You can always find a value for y when you plug in an x here. Okay? All right, so go ahead and finish up those other ones. Keep working at them. I'll call you guys up using the random number table here in a minute. Just to get those next 3.
It's not recording.
It is.
Oh, it is.
All right.
Okay.
You got number 9.
Yeah.
Josh, you got number 8.
Yeah.
I'll get someone up there for 10 here in a minute.
Wait, are you really recording?
Really?
Are you gonna oh, wait. I want a picture.
I'm Big Daddy.
Shout out to the homies. Okay. Except for my, that's not cool, guys.
I can't say anything. Hey Anderson, grab me a ruler. Hey yo Anderson, hit me up with that ruler.
Here's a ruler, right here.
Darren Benjamin, you got number 10? Number 10, Darren. I dare you.
Which one?
What's up, Jacob? What's I'm like this? This is my friend. No, you wouldn't. You'd be like Good job,
Oh
Josh.
no.
Good thing you're using a pencil.
Yeah.
Mechanical pencil.
A big mechanical pencil.
regular horse.
We'll find
I'm
out.
like that big.
I hope not.
I think I did it wrong.
That's how big I am right there.
That's how big you are.
Yeah, you did it
Hey, make sure you're asking if you need help.
Yeah.
Dang, that's huge.
I need the opposite of him.
Just kidding, I'm like,
You're like 3 inches.
No, it's personal. To read your mind. I didn't see the positive, so I thought it said.
Oh, we'll talk about it. That's a good teachable moment. It's a good teachable
I'm a
moment.
shore girl.
Let me teach.
Can I just redo it?
You're a girl, then you're like, probably like up to there, then.
No, can't redo. We're redos right now. That's okay.
Until it gets down to like.
Okay, here we go. Oh, we got. Hey, could I please have your attention up here?
Oh, you forgot the lines.
What? Wait, what did I forget?
Hey, everyone.
Oh, I didn't write down.
Did we do this yesterday? 5 seconds. I ask. I want it. Okay? You guys figure that out. Come on. Now look, right here, if we have negative x plus 1, or negative times the absolute value of x plus 1, the negative says it's opening down. That's good. Looks like our vertex negative 1 because it's opposite of that.
Negative 1, 4.
And positive 4 because that's our k. Good, so we got that. And then down 1 over 1. So we're good. All right, well done. We'll put arrows on the end because it goes on forever, which helps us if we were to figure out the domain. All right, number 9. Number 9,
No.
Abby says is wrong. So Abby, what did you got?
What?
What'd you do wrong?
To move it over to the negative one because I didn't see it.
Good, so it has to be opposite us. So that should be negative 4. So we should be over here.
Oh.
And positive 2. So Abby figured that out, but I wouldn't let her change it. Just because it lets me, gives me the opportunity to teach, which is the joy of my life. All right, so there we've got it. This one right here, we would want to scribble out or erase, actually. Here, I'll erase.
So I have to redo this. Whoa, this one's cool.
Neato burrito. All right.
Oh my gosh, I said this earlier. Who says that all the time?
Good, we got positive 1, right? It's opposite. Should be a positive 1. And that should be positive 1. So we should be right there. Okay? You understand? And we would definitely want the lines. Otherwise, we're doing a discrete function, which we don't have discrete data there. We have continuous data, which means after we put the dots, we need to get the lines in there. All right, so it looks like we're able to hit on a few misconceptions there. Definitely want those. Okay? Questions? That's not good. All right, number 10, what's our vertex?
2, 4.
2, 4.
2, 4.
6, 8.
Not quite as good as 10, 4. Josh. Yay. Oh,
10, 4. Wait, I don't get it.
you didn't finish. Do you get it? Like 2, 4.
6, 8. Who do we appreciate? Josh.
Josh, you didn't have to start a song just to get us to say we appreciate you, man.
Yeah,
Here we go. 2, 4. Okay? This last one, what's our vertex? 1, negative 1. Well done. All right. Oh. Questions? All right. So summarizing what we've done. Now we should know the value for A gives the width. Okay? It tells whether it opens up or down. So if we're dealing with slope, if I were to give you the equation y equals 1/3 times the absolute value of x, and then the equation y equals 3 times the absolute value of x, which one of those two equations would give you a narrower graph? 1/3 or 3? Which one would have your graph be wider or narrower than the other? Which one would be wider? Which one would be narrower? Go and tell your neighbor. Tell them why. How you know it.
3 is 3 is.
Okay, which one's wider? Which one's narrower? Tori. 1/3 is wider. Okay, so this would mean from my vertex, I would rise 1 and then run 3 in each direction. This would mean I would rise 3 and run 1. Think about the graph of our lines. Okay, this line right here, a straight up and down line, what's the slope of it? Stay with me.
Undefined.
Undefined. What's the slope of this line?
0.
That is 0.
0. So if you think about a V shape, okay, a V shape, as we go from that to say that to say that, and we keep getting further apart, less wide, we're approaching a slope of 0. Okay, so eventually we would just get a flat line. Okay, that would be a 0 slope. As your number, your A term approaches 0, the wider it gets, the flatter your graph gets. Does that make sense? If this is a slope of 0, then as you're approaching 0, your graph's going to get flatter. And that happens in all your graphs. Eventually, like, let's say maybe this is 3, maybe this is, I don't know, 1, maybe this is 1/2, maybe this is 1/3. This is 0. What's going to happen when I get to negative 1/3? Yeah.
It's going to start being wider again.
It's going to start being wider again, but
it'll still be as thin as 1/3. I mean, as wide as 1/3 upside down.
yeah, it flips inside out, right? Okay? It flips it over. Then you have the width going that way. So you keep going until these branches end up breaking and falling downward because it's a negative slope. Make sense? Yeah, that's not too good. That's sad. All right. Hey, let's see if we really understand. I want you to try to graph this problem. Last one that we're going to do together. Try to graph that one, please, based on what we've done so far. Identify HK. Hey, first thing to figure out is the vertex. Vertex is our HK. What's our H in this one?
1.
Good. It's 1. It's opposite of this, so it's 1. What's our K? 2. Start at 1. Go to 2. What's our slope? 3. So our A term, we rise 3, and we run 1. Okay? And then we reflect them, or just rise 3 and run 1 the other way. So it's quite a narrow graph, right? All right. How many got it? Yo, burrito, man. Questions? Yeah.
So how come a 3 can't affect the -1 in the absolute value signs, but a -1 can?
The negative flips it. So, for instance, if I put a value of, let's say 2 right here. 2 minus 1 is 1. Right? Absolute value of 1 is 1. And then times 3. So 1 times 3 ends up giving me 3. If this was negative, it would give me -3. That's how that changes it. So the 3 still affects it. It just doesn't make it flip. Because when you have a negative out here, you end up multiplying your result, whatever's in here, by a negative. Okay? Other questions? Okay. Very good. So today's assignment, I'm going to give you that. Very similar to yesterday's, but you're going to have to do your domain and range. So while I'm handing that out, I want you to tell your neighbor what the domain and range of that graph is that we just completed. Okay, so domain. Domain refers to our x values. What is our domain here?
All real numbers.
Good, all real numbers. It goes on forever. No matter what, I could always pick a value for x and get an answer out here. If I put 100 right here, I have 100 minus 1, which is 99. Absolute value of 99 is 99. Multiply that by 3, I get 297, and then add to 299. I get a value. When I input a value here, I always will get an output. Okay, and my graph goes on forever showing that. Yeah? No, not right now. I don't want to go into what a non-real number is. Okay?
Is 0?
Yes, 0 is a real number. Every number you've studied forever is a real number. I'll give you an example after our lesson. That way I'm not confusing people. Range.
Yeah, because it's really confusing.
I hope it's not. Well, it would be confusing if I start adding it in here. Range, what's our range? Yeah?
Would it be y is greater than or equal to 2?
It is. Y is greater than or equal to 2. We always look right there, or on a graph, we look at where it starts, starting here and going upward. Okay, so it's y is greater than or equal to 2. That means if I picked any value for y down here, pay attention. Give me a value that is not greater than or equal to 2.
1.
Yeah?
1.
Okay. 1. Give me an easier value.
0.
0. If I put 0 in right here, I should not get an answer out. There should be no possible way for me to solve this equation. If I said 0 is equal to 3 times the absolute value of x minus 1 plus 2, and I said solve that, hopefully you guys would recognize, well, you subtract 2. You get negative 2 is equal to 3 times the absolute value of x minus 1. And then you divide by 3. Now the problem becomes, when I divide by 3, I am now saying an absolute value is equal to a negative. Can an absolute value ever be negative? No. How come?
Because
an absolute value is just a place from 0, and you can't have a negative place value.
Okay, it's a place from 0. It's not a place, but it is something from 0.
Distance.
It's a distance, and you can't have a negative distance. So this is no solution, and we knew that because the graph doesn't have a value here at 0. Okay, this won't work. So when we put 0 in for y, it doesn't work out. Why? Because only values that are 2 and larger will work out in this equation. Will give us true statements, and we see that with our graph. Okay, remember, a graph is just a picture of all your solutions. That's what you have there. All right. Danny wants to know what a non-real number is. This is a real number. This is a non-real number.
pi. Yeah.
This is real. What is that?
4. Square root of 4.
Yeah, which is 2.
Oh.
This is non-real.
Negative.
Why? Because we can't take the root of a negative in our numbering system. Now, when you get to advanced algebra, we tell you that this is actually 2i. So where you guys look back there on the panda's hat, it says root negative 1 love math. Well, root negative 1 is the I, is the value I in math. Now, you don't need to know that yet, okay? But that is called a complex number. So you have all the real numbers, and then you have these imaginary numbers. They're floating around you at all times. You just can't see them. I know, it's pretty cool. Imagine that, huh? Sounds like pretty complex stuff to me. Okay?